Okay, I thought I messed that up and I did not, so yay for that. Took a little break, coming back all refreshed. I do want to say quickly before I forget, I did forget I lost my pen. I did forget the phrase on K on the last lecture. I forgot the phrase. I'll post an announcement about that. Excuse me. My root beer's getting me. Anyway, I wanted to say what today's silly phrase is. You guys listening? You ready? Okay. So today's silly phrase is my slippers are planning a world tour. Yes. My slippers are planning a world tour. Okay. So let's get back to more serious business. Let's talk about something called the Bayes theorem. And this is something that is practical. It seems impractical, but it's very practical and it is commonly used in the medical field. And I know that, I don't know why I keep on hitting that button. I know many of you guys are pursuing nursing degrees and such. So you'll certainly see this again. Now, do not freak out. This looks very scary. Please don't be too scared. Okay. So first, this is Bayes' theorem with variables in it. Okay. We're not going to think about it particularly like this. We're going to use it in this form. And I also am going to tell you, I will give you this formula. I will always provide this formula, okay, on exams and quizzes, even as I mentioned before I took my little break, that this is always a bonus question on my final exam. I will even still give you the formula for the bonus question on the final, okay? The sun's starting to go down or it's getting cloudy or something, so y'all are losing it. It's just the natural light and the camper keeps on changing. Anyway, let's get to it. Now, it's really important that you can read and understand conditional probability. So I'm going to write a little bit of stuff over here on the margins, and I sure hope that it stays in the recording. It should, but let me write a few things over here. So you've got to keep the notation straight. So if I write the probability of bird given cat, okay, this is, I just want to make sure you know what this says. This says, what's the probability okay, sorry, probability that you draw a bird given you have drawn a cat. Let's just pretend like it's cards that have birds and cats on them. I don't know. Okay. Right. So that's the wording there. Okay. And also, if I said something like the probability of blue, given you've drawn red, given you've drawn orange, that means that probability of blue after you have gotten a red after you got an orange. Okay, so after and after. Remember that they're read this way when you're computing them. Okay, now I bring this up because I want you to notice something over here in these formulas. So let's get over here to the base formula. Let me get in the green. I like green. Let me get in the green here. Okay, so here's the base formula. And I want you to notice what it says here. This is the probability that you have been given a positive result on a medical test and you actually have the disease. That's what this says. The probability, what is the chance that you have the disease given a positive test? Okay, so this is the probability you have a disease given you tested positive for it. Okay, that's what that says, but I want you to notice how we get it here. So it is the probability you have disease times the probability you have a positive result given you have the disease. So you've got to see that this is different than this one. See, this one is disease given positive result, and this one is positive result given you have the disease. So this is positive result you have the disease. Okay, so and then here we also have this positive disease times times the probability of your positive given you have the disease over the probability of the disease times the probability that if you have the disease, you have a positive, or that you get a positive test, given that you know you have the disease, plus the probability of having no disease. So, by the way, that's the probability of disease bar, and then the probability that you have a positive test given no disease. Now, these things here have their own special words, own special language here. And so I'm going to get onto this first example here. Okay. So let's read it. A certain disease has an incidence rate of 2%. Okay. An incidence rate is the probability of disease. So this, what happened there? This is the P of disease. And we don't do any calculations in percentages. That's 0.02. Have to convert percentage to decimal. Okay. If the false negative rate is 10% and the false positive rate is 1%, compute the probability that a person who tests positive actually has the disease. actually has the disease, okay? Now, let's dig into some of these other words here. So, the probability of positive given the disease is called the false negative rate. Okay, so the false negative rate gives us the people that tested positive and have the disease. So these are, gives us people who tested positive and had the disease. This is called the false negative rate. Okay. And that is given by 1 minus the false negative rate. That is 1 minus 0.10, which is 0.90. So the probability, false negative, is the people who tested positive and had the disease. So this is people who tested positive that already know they have the disease. That is going to be equal to 0.90. Notice what we did here is we had to use the complement. We had to use the complement. Okay, so now, right now, we have the probability of the disease, the probability that we test positive given we have the disease, and then we also need the positive given no disease, right? Because there's basically, we've got 2 of these guys. These guys are the same. Okay, this is the exact same. This is the exact same. So what do we have left? Well, we need to find probability of no disease and also the probability of having a positive test given no disease. Now that is called a false positive rate. So false positive rate is 1%. The false positive rate is the people that tested positive but do not have the disease. So false positive those are the people that tested positive but don't have the disease. Okay. And that is given generally straight up. It says false positive rate right there. And that is going to be P of positive given no disease. And that is equal to 1% or 0.01. Okay, so we got that guy. And we need this one. This one's pretty easy. So the probability of no disease is the equivalent of the probability of, we can write it this way, no disease. That is 1 minus the probability of having a disease, right? The complement. And so this is 1 minus 0.02, which is going to give us 0.98. All right, and I think, yes, and then we'll just plug it in here. All right, so let's get it here. So the probability of having the disease, given we tested positive for it, is equal to, and now we have P of disease, which was 0.02 times probability that is positive given you have the disease, 0.90 over, and be careful, make it a long over, and then we have the exact same thing for the numerator. So that's the numerator. Plus, now we've got the no disease times the positive and no disease. Be careful when you put this in your calculator. This entire bottom needs to be in its own set of parentheses. And when you compute all this out, let me see, what did I get? 0.6475. So we can say 64.75% chance you have the disease given you tested positive. Now, and this might sound absolutely obscure and crazy, but it's very, very true when you really start getting into science. Like when you try to diagnose somebody, say with cancer or something like that, it takes multiple different tests to come up with that conclusion, because a lot of these tests throw false positives, or more scary, false negatives, which is why like sometimes my mother had a biopsy not too long ago, within the last few months, and it required them to biopsy it 17 times to decide whether or not it was cancer. And miraculously, they said it was not cancer. And then 4 weeks later, she lit up a PET scan with lung cancer and cancer all over her body. So it just goes to show that even if you use the science and stuff, it's going to help you kind of triangulate and get to something, but you're not necessarily ever going to have a whole lot of tests that have 100% efficacy, is what they call it, they're 100% efficient. That's just not possible. So this is something that is used constantly in healthcare, and you might find it a little bit concerning that a test might not be what you would think would be 100% accurate, right? But it's also something that you should know, especially if you're going through anything and you've got a test that comes back that says precancerous cells or suspicious for cancer or something like that. So lean into the fact that, it might take several tests for things to get figured out. But this is how, oh, so sorry. This is how this Bayes theorem stuff works. I'm going to throw one more example here at you. You will have some homework to do here. And we'll see if I put up an additional little extra tutorial on the Bayes theorem. So we'll see how that goes. Okay, let's take a look at this particular problem. Now, I'll tell you when I work these that this is usually what my paper looks like. I write P of disease. P of not disease. Because these are all the things that I have to use. There's only 4 things I need in my formula. I need P of disease, or wait, sorry, wrong direction. Positive given disease. So positive test given we have the disease. And then we also have the probability of positive given no disease. All right, let me see here. Let me write this. The positive no disease is also called the false positive rate. And the positive given the disease is called the false negative rate. And remember, with either one of these, you might have to use a complement to get what you're looking for. But most often, it's with the false negative that you have to do that. So this guy right here is the one that you usually have to do some computation to get. The rest of them you can read straight off, but these two you'll have are kind of complements here. Okay, so let's get back here to our question. And our question says a certain disease has an incidence rate of 0.5%. So I'm going to glom onto that. That means probability of the disease is equal to 0 point, got to move that decimal place 2 places to the left to turn it back into a decimal. And that's what we're going to have here, 0.005. Now the probability of no disease is 1 minus the probability of disease. So that's going to give us 0.995. Okay, it says there is no false negative rate. There is no false negative rate. That means that the false negative rate is 0. And because we use complements here, I'm just going to write it like this. 1 minus 0 equals 1. Okay, these are the two that you have to do 1 minus whatever the value they give you generally. Okay. And finally, then it says the false positive rate is 3%, and this is the straight false positive rate, so that is going to be 0.03. Okay. Now we just plug and chug it in. So this is going to be equal to probability of the disease 0.005 times the probability that we have that we're positive given we have the disease, positive given we have the disease is times 1 over 0.005 times 1, because whatever you wrote on the numerator, you write it down again in the denominator. It's the exact same thing here. Plus, and now we've got 0.995 times 0.03. And when we crank this out and we get our answer, we get 0.1434. And when we interpret that, we can say 14.34% chance that you have the disease given you had a positive test. Now, some might say that this is a very crappy test if its effectiveness is only about 14%, right? For sure. Okay, well, we did it. Now, I know that this Bayes theorem stuff is a little bit hard. I hope that you go back and take a look at it. Rewind, watch it again. I hope that you come and talk to me and ask me questions if you need some help on it, because it can only help you if you're doing well with it. All right? Okay. I think I'm done. I hope y'all have a good day, and I'll talk to you soon. Oh, please watch and read your announcements, darn it. Watch and read your announcements. It's the only way I can really communicate with you other than the lectures. Try to keep the lectures non-specific so I can use them again. All right. Y'all have a good day.